So up here I have a little recall. X to the 0 power. Who remembers what that equals? Not 0. 1. Anything raised to the 0 power equals a 1, always. So I could have 1 million raised to the 0 power. It's going to simplify to a 1. I could have 500x cubed all raised to the 0 power. It'll equal a 1. Anything to the 0 power is a 1. So that's something we're going to be using today. So what we're going to be doing today is we're going to be multiplying monomials times monomials, which if you remember, that means it's one term times one term. So to go through that, we have some special rules, but let's practice this out first. If I was multiplying 2/3, or 2 to the third times 2 to the second, if I wrote it out the long way, 2 to the third means that it's 2 times 2 times 2. That means you got 3 2's there you're multiplying. 2 to the second means that it's 2 times 2. So how many 2's do we have all together when we're multiplying that? 5. So that means this is really 2 to the 5th, which, does anybody know what 2 to the 5th power is? Don't tell me 10. 32. Good. So the same thing works if we have letters instead of numbers. So a to the 4th means that it's a times a times a times a. You're multiplying 4 a's there. A to the 3rd means that it's 3 a's. A times a times a. So how many a's do we have all together? 7. Does anybody see the pattern there? What's happening? You're adding your exponents. So what happened is many years ago, they would do this. They would write it all out, and then they'd count on how many they have, and that they figure out that's what the exponent was. And then all of a sudden, somebody's like, oh my gosh, all you have to do is add them. And it made our life so much easier, because if you have like x to the 13th power times x to the 27th, you don't want to be writing those out 40 different times. So they figured out this little rule that all you have to do is if you're multiplying with the same base. So your base here was a 2, so I had the same base. Our base here was the a. So remember, your base is whatever has the exponent attached to it. So if you're multiplying with your same base, then we simply add the exponents. So my example here, my base here is an x, so I keep my base of x. I'm going to add my exponents. So it would just be a plus b. Can't actually add an a and a b because they're not like terms, but if they were, we would do that. So in our next example, 3 to the 4th times 3 squared, we have our base of 3, then 4 plus 2 gives us 6. And then let's figure out what is 3 to the 6th power. $729. So when you also have coefficients like our next one, your 3x times your 5x to the 3rd, what you would do is you would first multiply the coefficients. So in my example over here, first thing I would do is I would multiply my 3 and my 5. So that would give us 15. Then you do exactly like we were doing. You keep your base, and then you add your exponents. So our base here would be an x. Who remembers, what's the exponent on that first x? 1. We don't always write the 1s, but they're there. So 1 plus 3 gives me x to the 4th. So we get 15x to the 4th for our answer for that one. So let's do some examples down here. So number 1, we got a base of c, so we do what with our exponents? Add them, so we get c to the 6th. Number 2, we got some coefficients in there, so we got to multiply our coefficients first. So negative 2 times 5 would give us negative 10. And then we would get x to the what? 6. Three, multiply your coefficients first. Negative 3 times negative 4 would give us a positive 12. And then let's look at the a's. A squared times a to the 4th would give us a to the 6th. And then b to the 3rd times b to the 1st gives us b to the 4th. So deal with the a's, deal with the b's. All right, number 4. Remember, our coefficient, if it's not written, is a 1. So when I'm multiplying here, 1 times negative 3 gives me negative 3. And then x to the what? Negative 2. Because you have this 1 plus your negative 3 would make it x to the negative 2. And then 3 plus negative 2 would be y to the 1st. So that ends up being our final answer right there. So number 5, our base is a 3. Negative 5 plus 2 plus 7, 4. Now whenever it's a number like that, you actually have to figure out what is 3 to the 4th power. 81. Can't do that with your letters, but with your numbers you always have to do that. And then our last one up here on the front, negative 4 times 5, negative 20. A squared times a to the negative 2. You get a to the 0, so that would be a 1, so it's really like it's 20 times 1. And then b to the 1st times b to the 4th would be b to the 5th. So negative 20 times 1 is just negative 20 b to the 5th. So whenever that happens and you get an exponent of 0, it's just basically like that letter cancels out. You don't have to keep putting the times 1 there. So negative 20 b to the 5th. Going on to that next page. So remember, when you have anything in front of parentheses like this, we have to distribute it so it would become a times b. So there's my a times b plus a times c, which is there. It also does the same thing with our polynomials. You just have to remember, when you're multiplying, like for example your x's, you got to add those exponents. So for the first one, we're going to distribute 2x. So we're going to do 2x times that x squared first. So that would give us 2x to the 3rd. You multiply your coefficients, add your exponents. So 1 plus 2 gives me x to the 3rd. Then we multiply the 2x times the 3x. So 2 times 3 gives me 6. X times x gives me x squared because I add my 1s and it gives me the 2. And then 2x times 4 would give us 8x. And then that right there is our final answer. It would not, because there's no x with my 4. It's just a 4, so it only gets multiplied times the 2. So number 2, again, we're going to do our distributive. So I'm going to multiply the 3z to the 4th y times z cubed. So that's going to give me a 3. I'm going to add my exponents on my z, so that gives me a 7. And then the y is still there because it was in the term on the outside of the parentheses, so it still has to be there when you multiply. So then I have to multiply it times the negative 2y. So 3 times negative 2 gives me negative 6. I got my z to the 4th. Y times y gives me y squared. I add my exponents and I get a 2. All right, what's different about number 3 than the other two that we had? There's 2 things. So we have to distribute the 4 through the first set of parentheses, and then we distribute that minus 3 to the second set of parentheses. The number only goes through the parentheses that comes after it. No other sets that are after it after that. So 4 times 2x squared would give us 8x squared. And then the 4 times negative 3 will give us a negative 12. There's no x with your 4. But it's not x to the first. It has to be a common base. It would have to also have an x. So then negative 3 times negative 2x squared would become positive 6x squared. Multiply your numbers. And then negative 3 times negative 5 is a positive 15. So now this combines also in the skill that we did last class. We now have to combine our like terms. So 8x squared plus 6x squared would give us a 14x squared. And then my negative 12 plus 15 would give us a plus 3. Now that's our final answer. So in number 4, what would we distribute through those parentheses? The negative 2y. Good. I have a lot of people who tell me you subtract those first, but you can't. This 2y is attached to the parentheses. So you have to distribute that through first, and then you can combine your like terms. So my 8y is going to stay as 8y. That's not going to change for right now. So negative 2y times 7 will give us negative 14y. Yep. Negative 2y times negative 3y becomes positive 6y squared. Because you got the y times y, so my exponents, when I add them, 1 plus 1 gives me 2. And then this plus 5 at the end doesn't change because that's not inside the parentheses. So I'm not multiplying that times the 2y. That stays as 5 for now. So now when I combine my like terms, I'm also going to put my answer in standard form. So that means I'm going to start with my y squared, which the only y squared term I have is that 6y squared, so that's going to come first. So then 8y minus 14y. Very good, negative 6y. And then we got our plus 5 at the end. So there's our final answer, 6y squared minus 6y plus 5. All right, and then number 5, we're going to distribute that 1/3 x through. So 1/3 times 3, what would that give us? 1. So then x to the first times x squared would give us 1x cubed. You could put the 1 in front of it, but remember, you don't have to put a coefficient of 1. So then 1/3 times 15. Good, so negative 5, and then x squared, because x to the first times x to the first. Add your exponents, we get x squared. And then 1/3 times 27, and then we have our x there. So there's our final answer. X cubed minus 5x squared plus 9x. So then down here, area goes along with multiplying our polynomials. because area generally means to multiply. For a square, does anybody remember the area formula for a square?
No, I remember for a rectangle.
Okay, what's it for a rectangle? All right. Isn't a square just a fancy rectangle? So area is also length times width.
And then triangle, it is 1/2 base times width. Okay, just cut me off, because I was just going to say that. No.
All right, so for our square, when we plug in our length and our width, they're both going to be 5x cubed. Your length and your width are the same in a square. Yep, so now we multiply our coefficients, we get 25. Add our exponents, we get x to the 6th. 25x to the 6th would be the area of that square. So for our rectangle, we're going to have the 3x times the 6x squared minus 6x. So 3x times x squared is 18x cubed. 3x times the negative 6x is minus 18x squared. So then the last one, area of our triangle. So we got our 1/2. The base is 4x squared. And the height is 8x. Now there's a couple of different ways you can go from here. You could do the 1/2 times the 4x squared and then multiply it times the 8x. Or you could multiply the 4x squared and the 8x first and then times the 1/2. It does not matter which way you go. You're still going to get the same answer. So when I multiply my 4x squared times my 8x, that gives me 32x cubed. Add my exponents there. 1/2 times 32 makes that 16x cubed. So our last thing we have here is what we refer to as a power to a power rule. What that means is you have something raised to an exponent, and then it has another exponent on the outside of it, and we call those exponents powers. So you have a power raised to yet another power. So that's our power to a power rule. So what you do is you're going to keep the base, and this time you multiply your exponents. So if I have x to the a raised to the b power, this is going to become x to the ab. You multiply those two numbers. So for this one, you've got to give this exponent here of c to both parts of the expression on the inside of the parentheses. So that would make it 2 to the ac and then x to the bc. You got to multiply the exponents on the 2 and the exponents on the x. Now the reason why this works, like if we look at the first one, another way we could do these problems is since this is squared, I could write it out twice and then follow my multiplication rules from before, which would make this x to the 8th because 4 plus 4 is 8. But again, somebody many years ago figured out this rule that when you have these two exponents here, if you just multiply, you get to skip that step and it takes you right to the answer. So again, if your outside exponent is like a 10, you don't want to be writing that stuff 10 times and then multiplying. So they came up with a little shortcut there of multiplying your exponents. No, that was just me explaining why the rule is what it is. You're fine. Yep, you'll be fine. So here for number 2, again, this exponent of 4 has to go to all 3 parts of the expression in there. It has to go to the 2, it has to go to the a, and it has to go to the b. The exponent on my 2 currently is a 1, so 1 times 4 makes that 2 to the 4th. The exponent on our a is currently a 1 also, so 1 times 4 makes that 4. The exponent on the b is a 1, so 1 times 4 makes that 4. So then we just have to clean all of them up. What is 2 to the 4th? 2 to the 4th. 16, thank you. So 16, a to the 4th, b to the 4th would be our final answer there. So number 3, again, same thing. This exponent of 3 has to go to all 3 parts. It has to go to the -3, it has to go to the x, and it has to go to the y. So that means it becomes -3 to the 3rd, because the current exponent on your 3 is a 1. 1 times 3 makes it 3. We have an x squared, so we have to do 2 times the 3. So that makes it x to the 6th. And then y to the 3rd, because 1 times 3 makes that a 3. So we just have to clean up our number. What is -3 to the 3rd power? No.
Oh, yeah.
-27. So there's our final answer. -27, x to the 6th, y to the 3rd. All right, 4th one. If you notice, this first set of parentheses has an exponent outside of it. The second set has its own exponent. And then they want us to multiply. So just like you would do in your order of operations, you would do exponents before you multiply. We do the same thing here. So we have to take care of this exponent by multiplying it both times your x and your y. So this gives us x to the 12th and y to the 8th. 3 times 4 gives me 12. 2 times 4 gives me the 8. Now I have to distribute this -3 through my second parentheses. So that gives me x to the -6. 2 times -3 gives me -6. And then y to the what? 9. Now we're just multiplying. So this goes back to our first set of rules. When we're multiplying, what do we do with our exponents? Add. So for our x is 12 plus the -6 gives us 6. We got x to the 6th. 8 plus 9 gives us 17. So we get x to the 6th, y to the 17th. So number 5, what do you think we're going to do first? Yep, multiply that exponent into the parentheses. So this gives me x6, y4. And then I bring down that term that was in front of it. I bring down that 7x to the 6th, y to the 4th. And now this is like last class. We're adding. Do our exponents change when we're adding? No. 7 plus 1 gives us 8x to the 6th, y to the 4th. That's honestly the tricky part. When you do each rule by itself, it's pretty easy. You guys can go pretty quickly. When you have to combine some of them, you have to be careful. Because that's a 1, so 7 plus 1 give me my 8.